Hi, everybody. Oh, that's just terrible. Terrible. Hi, everybody. Hi. I appreciate that. Thank you so much. Well, everybody, very good. Thanks for coming. We still have spots. What's that about? Do we? No, we don't. I was just kidding. There's two. There's two over there. The rest of you are there's resource contention here. Well, anyway, grab a seat if you can. Welcome, everybody. I'm so glad you're all here. It is an honor for me to be here. I haven't been here in a couple years, so it's super nice to see all of you, to see these wonderful smiling faces. Are you having fun so far? Yeah. Oh, me too. This is a great show, and it doesn't hurt that it's also snowing outside. So staying inside and getting all this knowledge feels even better, you know. So anyway, we're going to go through a lot of stuff. Oh my goodness, we're going to go through so much stuff today. We've only got 50 minutes, but I figured we might as well just try and do everything as much as we can today. So I'm going to go through as much as possible today. So with that in mind, I encourage you to take note of that Git repository there at the top of the slide. That Git repository contains code that you can use to follow up later on. If you have questions, comments, feedback, whatever, I'm happy to answer those questions. How many of you, by show of hands, how many of you are on Twitter? I'm just curious. Twitter. All right, the rest of you, get on it. It's a great place to be. It's the new IRC. It's where all the developers that drive the open source that powers your business are. And if you want to engage in the industry and to sort of engage in that software, you owe it to yourself to be there. We're happy to respond to questions. We're happy to chat. We love any and all feedback. I'm on Twitter. I'm at Starbucks, man. What about email? Anybody here using email? Email. Anybody? No. Very good. All right. I don't have a fax machine either. It's fine. We're in a post-Slack world, people. So moving on. A little bit about myself. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm an open source engineer, a Java champion. I've worked on a number of different open source projects in my 8+ years now as part of the Spring team. I have been, in my time with the Spring team, I've had the dubious distinction of being the number one, most prolific, most visible, most highly acclaimed, highly lauded contributor of bugs, but still number one. Number one. It's important. It's a record. It's all I got. It's a good one. And I'm a Java champion and a Spring developer advocate. As part of that, I do training videos and books and so on. So I have several of these videos these are training courses on Safari, the online technical marketplace. Netflix style, all you can eat buffet style subscription for technical content and books and all that. And I write books. I've just finished my 5th book. It's called Cloud Native Java. And it's all about how to build applications that survive and thrive in the cloud. And the book, it took a little longer than I had expected it to. I'm not going to lie. It took a lot longer than I was hoping. We thought that we would be done in 6 months flat. 6 minutes. That's good even for Dr. Subramaniam. That's too good. We thought we'd be done in 6 months flat, but schedules and software engineers and estimates. So it turns out that it didn't actually take us all that much to write the book proper. The book itself was easy, right? I mean, sure, there's a moving targets. We had to contend with all that and constant updates and new cool stuff to talk about. That was a great problem to have. But in reality, the thing that was most vexing for those of us working on the book, the thing that daunted us for about 1.5 years after we largely finished the writing in the book, was the discussion on what animal to include on the cover. Anybody who knows anything about O'Reilly books knows that it doesn't all that much matter what you write in the book proper. It's everything to do with the animal on the cover. And so this animal took us a long time to get right. We deliberated, for, like I said, 18 months. It had to be, at least 18 months, maybe 50 years. It felt like 50 years. This animal is a blue-eared kingfisher. A blue-eared kingfisher. It's a bird. And by the way, did you know birds have ears? It's a bird that is indigenous to the Indonesian Java Islands. Indigenous, or as we'd say in English, native. So it's a bird that is native to the Java Islands. And birds, they fly. Yes, that's right. Through the clouds. Yes. So it's a bird that is native to Java that flies through the clouds. It's a cloud native Java bird. Never mind. It'll come. Thank you. There we go. Very good. And I work at Pivotal. And I should mention, by the way, friends of friends, that we are hiring lots of really smart people. I am the stupidest guy in the team, by far. Stupidest human on the team, by far, right? So please join us. If that's an itch that you want to scratch, we'd love to have you. We have openings and all that. Don't hesitate to reach out to me at that email or just hit that careers website, all right? And I work at Pivotal. And at Pivotal, we have a lot of great open source software. As I say, we have a lot of great open source software that we care very much about. And this software, we love open source. We work in open source. But let's be very clear. At the end of the day, it's not the reason we're here. It's not the thing that motivates us. It's not the reason that people like myself spring out of bed. What we care about, first and foremost, at the end of the day, is to help people build better software faster. And as part of that, we spend a lot of time talking to organizations about microservices, right? Microservices are a natural consequence of this refactoring for optimal sort of organizational capabilities. People move to microservices because it allows them to have small code bases. But when they move to this architecture, they get lots of small, singly focused, independently deployable network services, right? That's the sort of inevitable conclusion of that architecture. And when you do that, you introduce a situation where you have now lots of small services being conducted over the wire. These things need to talk to each other over the wire. And the conduction of that data presents a few problems. You've now invited the complexity of building a distributed system into your life, and that complexity, if you're ill-prepared to address it, is going to cause a lot of pain. So you need to be able to address that. And we talk about patterns and primitives that you can use to sort of address this complexity, things like circuit breakers and load balancing and all these kinds of concerns. And we're going to talk about some of that today as well. But one thing that becomes sort of obvious when you move to this world is that our traditional approach for doing I/O doesn't really scale in this world, does it? When you start thinking about moving a lot of data back and forth over the wire, now you've got services that are being saturated at the network layer by their needs to move data back and forth. And this creates a strain, first of all, on our existing services. Think about the way traditional I/O has been done on the JVM, right? Most traditional sort of services are based on traditional blocking I/O. The idea is that you have a selector front-end web thread pool, and the thread pool accepts new requests, and as each request comes in, we process the response and send it back out in the same thread. And as long as that process is happening, that thread is kept locked to that server socket, basically. Which is fine if the process is very quick, if the reply can be generated very quickly. But if you do anything non-trivial, then you're keeping that thread, you're monopolizing that thread. In the JVM, threads are very expensive. So this is an anti-pattern. You don't want to keep that thread open for too long. You want to be able to reuse it or dispatch it to something else so that it can process new incoming requests. Otherwise, you end up in a situation where you've got no threads able to respond to requests. And in the JVM, we're used to thinking like this because in JDK 1.0, we had input streams and output streams. And we're used to thinking about data that will be there eventually. And if we just sit here and wait, we can ask for the next byte and it'll be here eventually. But in practice, in reality, at the lowest levels of the operating system, in low-level C code from decades ago, there were mechanisms to say, here's a file descriptor, let me know when something is available, and when it's available, then I'll worry about it. But in the meantime, you manage it. I can do other things with my threads over here, right? So if you've ever used C, the select function in C, right? Or epoll or libaio, I mean, all these things in the lower-level operating system sort of primitives, all those things support asynchronously responding to I/O. So in Java 1.4, we introduced channels. Channels gives us that very same functionality. And you'd think that'd be it, right? Are all of you writing your code in channels? Your data access layer, your security, your web tier, all that stuff is done in terms of channels, right? Well, of course not. Most of us write our business logic in terms of higher-order computational metaphors that sit above channels, just as we don't write code in input streams and output streams. Our business logic isn't input streams and output streams. It's much higher-order kind of thing. So we've lacked a computational metaphor by which to describe this world where data will be available eventually, but it's not here right now. And so we haven't written our code at higher layers in that to work with that style because we haven't had a way to talk about it consistently. And there's been a lot of great work in that space. Obviously, the ARX extensions for .NET by Microsoft Research, I think they got the ball rolling. Lots of great companies, including, of course, Lightbend, nay, TypeSafe. They were pioneers in this space as well. RxJava was inspired by the Microsoft Research Extensions for .NET. They did a lot of great work here there as well. In 2011, the Spring team, we had 2 different projects actually at VMware at the time. One was Reactive, which is what we're going to talk about today, and another one was Vertex, and now that's at Red Hat, also great technology there. So lots of great technologies trying to solve this problem, trying to provide that common, consistent computational metaphor to address that missing use case. But nothing really became the one true standard. And so we all worked together to create a standard. It's called the Reactive Stream Specification. The Reactive Stream Specification models this missing computational metaphor. It gives us a type that we can use in a common way across our code bases to say, we have some data. It's not here right now, but it'll be here in 5 minutes. It'll be here in a couple seconds. It'll be here, next week. And we might have 1 record, or we might have 0 records. We might have 1 trillion records. Or we might have all the records in the world, right? And all the universe. As long as there's heat in the universe, there's going to be new records. Now we have a way of describing that, right? The Reactive Streams specification gives us this thing called a publisher. And this Reactive Stream specification is the sort of convergence by all these different groups, the Spring team and Lightbend at the time, TypeSafe, and Red Hat, and Netflix and RxJava. All these different teams worked on this specification. It has a very important type called a publisher. A publisher is a thing that emits values. You can have a subscriber that subscribes to the publisher. The subscriber is given each emitted item when it's available. When the subscriber subscribes to a publisher, it is given a subscription. And this subscription is very important. You see, one problem that you run into when you move to this world where you have publishers producing data is you run the risk of overwhelming the consumer. So you need a built-in mechanism to signal to the producer that I can't handle any more data. Don't send anything more. So that subscription has a method called request. The subscription is what the subscriber uses to signal to the publisher how much data it can handle at a given time. You can say, I want 10 more records, that's it, or I want 1,000 records, or whatever you're prepared to handle in one swoop. So that mechanism, that flow control mechanism, is super important here. In the context of reactive programming, that flow control is called back pressure, and it's what helps you build robust systems that you cannot overwhelm. Just like you cannot overwhelm a Kafka or a RabbitMQ consumer, right? They drain the queue as fast as they can, but no faster. You can't denial of service a consumer like that, right? The broker will absorb the rights. So we have these 3 types. We have a missing type that I forgot to mention, which is a processor. It's both a publisher and a subscriber. It's like a bridge type. It implements those 2 interfaces. And if you understand those 4 basic types, then you understand what you need to be able to work with any technology that supports the Reactive Streams API, including Reactive from the Spring team, including Akka Streams from the Akka team, including Vertex, including RxJava 2.0, etc. Now, is this enough? Are we done? I'd say no, of course not. Even still, we need to be able to write code at higher levels. Like I said, it's all about the computational metaphor and our ability to use that at higher levels. And so today we're going to talk about Spring Framework 5, which came out in September. We're going to talk about Spring Data K, which is our data access framework, and it is integrated with Spring Framework 5. We're going to talk about Spring Security 5. We're going to talk about Spring Boot 2.0. We're going to talk about Spring Cloud Finchley. Right? These are all technologies that allow us to talk about, to work with this reactive API, with the reactive stream specification, but to still benefit from the sort of rich domain and frameworks that we get that allow us to build these kinds of applications, okay? So, those are my slides. I hope you like them. What do you think? Best slides you've seen all day? There we go. Good stuff. At least the best slides you've seen this hour, right? So we're going to go ahead and build an application here at start.spring.io. How many of you know start.spring.io? Oh, that's so good. The rest of you. By the way, before I forget, I want to get a selfie. Okay, when I say open source, I want you to all say open source and then smile. Ready? Steady. Open source. Open source. And ready, steady. Open source. Open source. Oh, that's so awesome. Very cool. Thank you, friends. So we're going to go ahead and build a new application here at start.spring.io. This is my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. But if you haven't already gotten to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before your cup of tea or coffee, start. Spring.io. If your children are restless and can't sleep, start. Spring.io. And if you suffer from alcohol abuse, from indigestion after a long night of alcohol abuse, and PHP, start. Spring.io. So we're going to build a new application today. We're going to use Spring Boot 2.0. This is the new 2.0 RC1. This just came out last week, actually. So we're going to use that. We're going to build a new service here called the reservation-service. Actually, you know what? We'll go ahead and use the reservation service. We're going to go ahead and use that. We use the Reactive Webb support. We're going to use the actuator for observability use cases. We're going to use the, we're going to use the Reactive Web actuator. We're going to need Lombok to make short work of sort of the tedium of Java. We'll use that. We need to have, I think that's it for now. We need some sort of data access layer, don't we? Right? We need some sort of data access layer. And remember I said that we're going to use reactive technologies here, right? It's important that at no point do we actually block. So we're going to use truly reactive options here, right? I don't want to use a technology that's going to then sit there and wait for a response from the data source and block and monopolize that thread. That wouldn't be very useful. And I certainly don't want to provide a reactive facade on top of something that is fundamentally blocking either, right? I want to be able to have this go end-to-end, non-blocking as much as possible. So we have here a subset of the of the usual suspects from string data here that support truly reactive options. And there's a number of great choices here. We could use Couchbase. That's a great choice. That's fine for a lot of good, data models and domain models. And had I Couchbase installed, we might. Cassandra, also very good, very, very performant, very good choice. I don't happen to have a Cassandra cluster set up on my local machine, but if I had, that would be a great choice. Redis, that might be an option. Who knows? We could actually even talk about that later. Maybe we'll see if we have time. And so I'm left at this point with MongoDB, right? MongoDB is it's a great choice. If you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So for our purposes, I think I'm going to bring in the Spring, let's just bring in Kafka just in case. Let's see if I need that. We'll come back to it later. So I'm going to hit generate, and that'll give us a new project. I'm going to open this up in my IDE here. Okay, UAO reservation service.zip. Take some tea. I'm using IntelliJ. How many of you are using IntelliJ? I'm just wondering. Good stuff. Right on. Hot sauce. What about Eclipse? Rock on. Great choice as well. What about NetBeans? Anybody here using NetBeans? Awesome choice. I love NetBeans. What about Emacs? Anybody here using Emacs? Where's my Emacs guy? It doesn't seem to matter which city, country, or continent I go to. It's the same human being. Every single time I ask, who uses Emacs? I do. And then he leaves. Presumably to meet me again and troll further. Whatever. Anyway, I'm going to comment out some of the bits I don't need just yet. I don't need that for now. I think we're okay. So we have a Spring Boot application. Let's see what happens. Let's go ahead and start this application. Actually, we should go ahead and write some data to the database. So let's create a data model, right? I'm going to create a data model called a reservation. It's going to be like a hotel reservation or a restaurant reservation or something like that. It's going to have two fields. One is going to be an ID like this, @ID. Okay, and then it's going to be a document, a Spring Data MongoDB document. It's going to have a single lone field here called reservation name. Now, this is the essence of what I want to do, but it's Java, so I need getters and setters and all that stuff. So, no args constructor and data and all that stuff. That gives me toString equals all that kind of stuff, right? And I want to be able to persist instances of this entity into the database. So I'm going to create a repository, which is it's a pattern from domain-driven design. It's a type that allows us to handle the tedious, soul-annihilatingly boring read, write, and update and query logic that we have to do for all of our data access code, right? But it's not fun logic to write. So we're going to let the framework do that code for us. We're going to use a repository implementation interface here. We don't have to actually extend this or implement this interface. Spring Data will do that for us. It'll create a bean that provides the definitions of all the methods in this interface. And this interface should be very familiar if you've ever used Spring Data MongoDB, but you'll notice that the interface is now prefixed with reactive, right? This is a reactive Mongo repository that takes publishers from the reactive stream specification, right? These are things that produce values, and it returns two odd types that you may not have seen before. A mono is a publisher from Reactor. It's actually a type in the Reactor project, Reactor Core Publisher, that implements publisher, but it's a mono. A mono is a publisher that produces either 0 or 1 value. And then we have a flux. A flux is a publisher that produces 0 to n values, so 0 to unlimited values. Why do you need the distinction? Well, imagine you have a method that returns a publisher of t. Should you display a table to show all the records, or just a detail page with forms that you can update each record? How do you know, right? If you get a mono, you know you're getting 1 or 0 back. If you get a flux, you know it's a list perhaps, right? But you can treat them as publishers. That's the nice thing about this. They're both publishers. So now I can even create custom finder methods as usual. I can say flux of reservation, like so, find by reservation name, string rn, etc. Right? I can do all that kind of stuff that I would do normally. Now, what I want to do is I want to save some data in the database. I'm going to create a bean here called the initializer, right? So initializer implements application runner, and it's a callback interface. When Spring starts up, it's going to see this callback interface, and I'm going to inject the reservation repository in here and write some data to the database, all right? So now, we're going to write some data to the database. I'm going to say flux.just, and my name, we're going to write some names. So my name is Josh. It's super nice to meet you. What about you, buddy? What's your name? Martin, M-A-R-T-I-N? Is that right?
Yes.
Very good. Nice to meet you, buddy. Miss, what's your name? How do you spell that, my friend? A? Like that? Very good. I think maybe I lost something, but I hope that's okay. Is that okay? My brain is a little lossy. All right, let me see. What about you, buddy? What's your name?
Andreas.
How do you spell that?
A-N-D-R-E-A-S.
Like so? Very cool. That's 4 of us. What about you, miss? What's your name? Yeah. How do you J-A. Like that? Very cool. Nice to meet you. Oh boy, who wants to be my next volunteer? What about you, buddy? What's your name? How do you spell that, buddy?
A-L-O-K.
Oh, like that? Very cool. Nice to meet you. Uh-oh. What about you, miss? What's your name? Yeah, yes.
Anki.
How do you spell that, my friend?
A-N-K-I.
Like that?
Yeah.
Very cool. Nice to meet you. And what about you, buddy? What's your name? How do you spell that? Like that? Very cool. All right, thank you. So that's a nice round number. It's 8 names. That's going to be a nice symmetrical round number. If you divide it by 2 and then 2 again, it's still 2. It makes it easier for me to sleep at night. So I have now 8 names, and I've got them in a publisher. And what I want to do is I want to turn those names into a publisher of reservations. So I'm going to say map each name into a new reservation, like so. I'm going to say null for the ID and pass in the name. And what I want to do then is map that reservation into a persisted reservation. So this .reservation repository .save reservation. And of course, this could be a method reference like so. And what I get back from all this is a publisher of mono of reservation. And the reason is because the output of this stage in the pipeline is a mono of t, and then it's a publisher of monos of t, right? So we're not flat map it. Flat map means to unpack the previous stage, and basically I can now just talk about a publisher of reservations. All right, so that's certainly straightforward so far. We can actually clean it up a little bit here and just shortcut all of that. Very good. So what do you think is going to happen if I run this code as written? Nothing, right? These types are very much like myself, lazy. They don't do anything unless you activate them. So you have to subscribe to them, right? You have to trigger them to go. So you say subscribe, right? So here I can say system out print line. All right, subscribe, right? So that will work. Now, I want to subscribe, and then I want to print out everything that happens afterwards. So let's see, this dot reservation repository dot find all dot for each, or dot subscribe rather, system out print line. All right? I can do that, certainly. But is there any guarantee that this will happen after this? Of course not, right? These are reactive asynchronous types. So each stage in this processing pipeline could happen asynchronously. There's no guarantee that line 1 happens after or before line 2, unless you use the API to compose your code accordingly. So if you were to put a breakpoint in each one of these lines, you might see that they are executing on a different thread. You can control the threading. You can say subscribe on and pass in a scheduler, like so. Schedulers.elastic or from executor or whatever. But by default, there is a scheduler behind the scenes. So we need to force this line to happen before this. One way to do this is to say .block. But I showed this code, my friends. I showed this code to my partner. And she looked at me like she had made a terrible, terrible mistake. This is not the right way to solve this problem. We have this nice reactive API, and here I'm blocking. That's just wrong. So instead, I want to use the API. I want to say, do all that, then chain together all of this, and then do that. Now, if I run this code, what do you think we're going to see? Let's see what we'll see. I'll run the code now. All right, there we go. Seems okay. Looks like a little bit more than 8, doesn't it? And if I run the database again, what happens? There's a problem, isn't there? You see, how many of you know the expression in English, a broken clock strikes true twice a day? It means that even a broken clock, by virtue of the fact that its hands are fixed at one fixed time in the day, is correct at least twice, during the AM and during the PM, right? The same is true for MongoDB. It will, on occasion, persist your data. Not always, definitely not always, but a lot. Enough, sometimes. And so as a result, we can't take for granted that this data is still there. But on the other hand, it is still there. Look at that. I know that they work hard to lose it all the time. But it's here. So we need to clean up the database first, don't we? Right? This.reservation repository.delete all, then many, and we can stream this. Right? There we are. So here we go. And you maybe write this code a little bit differently. There we go. Look at that. So I'm going to delete all, then I'm going to write all the database data to the database, then I'm going to return everything that comes back. Actually, I want to, there we go, move that out to a separate nesting. So there we go. We now have a compositional pipeline, right? I'm writing data to the database. Now, I want to be able to build a REST API. We have data in the database. We can see this. It worked. Of course it worked, right? There's all the 8 records. Obviously that worked. Of course it worked. This was a demo. Of course it worked. It was always going to work. What did you expect? Instead, what I really wanted to focus on was this. You see, this is the ASCII artwork in Spring Boot. And this has been there for a long time. People who know about Spring Boot know that this is something that we've worked hard on. This artwork took a long time to get right, but you see, we have on the Spring team many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics, star stuff, the very celestial bodies in the heavens above us were their daily bread and butter. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue, something like, darn it, we need ASCII artwork. And of course, they did a great job. So it's for this reason I just want to take a brief digression to talk about what I consider to be a very serious, glaring deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. What the heck? That's a dumb feature. So I did what all of us would have done in the same situation. I'm no hero. You don't have to thank me. I was just doing my job, just doing my duty. Anybody would have done the same thing. I went on the internet and I cried loudly, and I was sent a message of hope from my friend, Jan Sebron. He's a software developer by passion at IntelliJ IDEA JetBrains. And he responded with this message of hope, which I share with you here today now. Don't worry, my friends. Hope springs eternal. So anyway, the fix is on its way, apparently. In the meantime, I wanted to talk to you about one of my all-time favorite features that we've just added to Spring Boot, to really entice people to upgrade, right? So what I'm going to do is I'm going to override the default banner. You know that if you have a text file here, you can actually go to source main resources and create your own banner.txt, for example, and that'll be used instead of ours if for some reason you feel like you're that good. But let's be clear, you're not. Now, that said, you can override it, right? And we have a new feature here that I think you'll agree is game-changing. Maven clean, Spring Boot, run. Thank you. Yeah. Sure, it adds like 30 seconds to my startup time. I don't even care. It's so awesome. So cool. Oh, that's so cool. Anyway, whatever. Moving on. We have now data in the database. I'm going to move that out for now for want of time. And we now have data in the database. I want to build a REST API, and I could do that using Spring MVC style endpoints like this: reservation, REST controller, and I can create an endpoint at getmapping/reservations, publisher of reservations. And what I want to do is return the data from the database and have it turned into a REST endpoint, right? So fairly straightforward. Reservation repository, like so. Add a constructor, this.reservation repository.findAll, okay? Let's see what happens if we do that. Go. So good. It's cached. So good. Makes me sad to even do that, but I had to. So beautiful. Anyway. Now you feel depressed looking at the old artwork, which we all agreed was like a Mona Lisa just a few minutes ago. But then I introduced the new one, and it just feels bad by comparison. So anyway, there's the data. We have a REST API, localhost 8080/reservations. There we are. There's our data. There's our REST endpoint. Now, keep in mind, this is a REST controller that's returning a publisher. This looks like Spring MVC, but this is not Spring MVC. We have a brand new web runtime here called Spring Web Flux. It's not running on Tomcat or any servlet container. I'm using Netty, completely reactive from the bottom up. So this looks very familiar, but I'm returning publishers. And think about what happens here. Well, first of all, it's running on Netty. I should say that you can run this on top of a servlet container if you want to. It'll do the right thing for requests and responses, because we can use the servlet 3.1 async responses, But for things like getting the session and the cookie, that's fundamentally blocking, so we just have to abstract. We have an adapter, kind of. You can do it, though, right? If you wanted to run this on, like, WebSphere, you could. Yeah, I mean, it's not a thing, right? But it could be. Don't do that. It's like if you had a Ferrari, and then you had like 10 elephants, and you put the Ferrari on top of the elephants. It's still a Ferrari, but it's not going to go very fast with elephants, So, please don't do that. Anyway, we have this brand new web runtime called Spring Web Flux. It's a completely brand new API, right? It works supporting these, Spring MVC style annotations, but there is no servlet API here by default. I can't inject my servlet API. I can't get it into HTTP servlet request. It's a completely different paradigm for writing my code. If you're using Spring MVC, then it should be very simple to move that over without any problems. But that said, keep in mind, this is a different engine. Now, I like this style, and this is certainly very conventional. If you've ever done Spring MVC before, this will feel natural. But there's a new style in Spring Framework 5 as well called functional reactive endpoints. And the way that works is you go to your bean configuration, Java config class here, and create a router function. And what I'm going to do is I'm going to use this DSL to create my mappings. I'm going to say, when somebody makes an HTTP GET request to the reservations endpoint, respond with this handler function, which produces a handler, a server response, right? In order to create this code, I'm going to inject my reservation repository here. So I'm going to say, server response.ok.body And what I'm going to say is I want to send back all of the data from the database, and the data is of type reservation, right? Think about why we have to do that, right? I've got this, well, first of all, let's clean this up. I've got this API, and it's much cleaner in Java 8. Spring Framework 5 and all the reactive stuff is Java 8 or later, so you cannot use Java 6 and 7 with Spring Framework 5. Now, I've got this API, and what I'm doing is I'm giving it a very specific type reference here. I'm giving it a type token, if you will, so that it knows what kind of T I have. I have a publisher of T. Well, what is T? It's a reservation. Java and Spring can figure it out, in this case, through the method signature. At runtime, using reflection, we can see the generic parameter. But for instance variables, it's not guaranteed that we can see that. So we need to have some way to tell the framework why, what this type is, what T is it. And the reason we need that is because Spring WebFlux is going to take every single value that comes from that publisher and incrementally turn it into JSON or XML or whatever, and then send that back to the client. Remember, that publisher could have 1 trillion items in it. So we can't just wait for the end of the document and then dump the whole thing into JSON and turn it into JSON, or to DOM and turn it into XML. Right? We have to sort of page through the results. So we need to know what a frame looks like, what the message frame is. Everything in Spring WebFlux is fundamentally geared towards being reactive, geared towards being a publisher. By default, we assume it could be 1 trillion items. And then if you want to just send 8, it works just fine. But by default, we write code as though it could be an unending amount of data that may happen now or in 5 hours. And the result is that it's very consistent. If you've used Spring MVC, then you know that when I wanted to do server-send events or WebSockets, it's a completely different paradigm, right? It's possible, but those things are asynchronous versus Spring MVC, which is itself very synchronous and blocking. So you have to do this code gymnastics to make it work. Now, if you want to do WebSockets, just give it a publisher. If you want to do server-send events, give it a publisher. If you want to send a REST response, give it a publisher. It's the same mental, sort of cognitive loop that we have to go through, right? Okay, so this is my endpoint. We have now an application that's up and running. We can manage the application. The application is up and running. I want to be able to see what the application is doing. I want to be able to understand the application. So in Spring Boot, we have this idea of Actuator. Actuator is a set of modules here that we have on the class path, and Actuator makes it possible for me to surface information about the application itself. And I can, let me restart the application here. I can surface limited subsets of information or all of it. And this is not new to Spring Boot and the reactive world, but it's important to understand that this stuff works now in the reactive world, right? It's not just tied to Spring MVC. So we have that now. I go here to Actuator, and I can see that there are all the dependencies, all the different endpoints, for example. And I can see, things have changed a little bit here. So if you're using Spring Boot 2.0 and you're used to Spring Boot 1.x, then make sure you check out the Actuator endpoints. All right, so we've got now a endpoint, and it's working. I want to be able to build a client that talks to that service. So what I'm going to do is I'm going to start up a new service here at start.spring.io, not Twitter, start.spring.io, 2.0. I'm going to build a reservation client, and this client will use the gateway, and I think it will use the reactive web support. And you know what I want to? You know what else I want to do? I want to secure this endpoint as well. So I'm going to go back to the build. I forgot to add in the security. So Spring Boot starter security, right? We can secure things in the reactive world as well. Think about how security works. Normally you have to answer 2 questions. Who's making the request, and what permissions does that person have when they make the request? What authorization do we give them? Spring Security has traditionally answered these questions and then put the resulting authentication into a thread local. Well, that doesn't really work in the reactive world, does it? So we have to adapt Spring Security to this new reactive world where the request may be processed on a different thread than the response. See what I'm saying? So Spring Security now does that. It's now reactive aware. So here we've got an endpoint. Let's go ahead and very quickly secure it. I'm going to answer 2 questions. The first is, which users are allowed to access the system? So I'm going to create a reactive user details service to answer the questions of authentication, like so. And I'll just hard code a map users thing like this, user.with default password. I'm going to build a user whose username is called user and whose password is called password because it's always password for reasons. And I'm going to say it's going to be the permission or the role is of type user. All right, there's my authentication. I could talk to anything, LDAP, Active Directory, OAuth, whatever. But I'm just going to use a username and password built-in kind of thing. And then we have to answer the authorization. So here we're going to config the server HTTP security, and we're going to say security dot authorize exchange. Well, first we're going to say build. That'll give us a security web filter chain, which is actually what we're going to be installing here, right? So return that. We're going to say we want to support HTTP basic. We want to disable CSRF, so disable that. And I want to support certain endpoints. So I want to say whenever somebody goes to, any endpoint, whenever somebody goes to reservations, I want that endpoint to be secured. Okay? So path matchers to this endpoint, authenticated, and otherwise permit all. So that one endpoint will be secured and everything else will be just wide open. All right? This is a good place to understand that you can also disable the code formatter for your IDE, like so. Right? So, right. There we go. That's not so bad. All right. So we've got now this endpoint. Let's go ahead and see what that looks like. Curl -v HTTP localhost 8080/reservations. Unauthorized, good. -u user password. Right? There's the data. So we know that's working. Now, what I want to do is I want to build a client that sees the data and allows me to process it. Okay? So I'm going to build a client here. I'm going to use Spring Cloud Gateway and the Reactive Web Support and Lombok. And I think that'll do. So let's go ahead and hit generate. CD UAO reservation client. Okay. And we're going to start this up on a separate port. Server.port equals 8081. Reservation client application. And here, what I want to do is I'm going to call that downstream service from a client, right? This could be an edge service, for example. It's a thing that lives at the edge, and it's the first port of call for requests that come into the edge service to the downstream services. So in order to make that request, I'm going to create a web client. A web client is our reactive HTTP client. We could have used the REST template. The REST template isn't going to be great for things that are long-lived, like long-lived I/O. So, for example, service and events or WebSockets, right? So we have a new client that you can use in Spring Framework 5 called the web client, which is reactive from the get-go, right? So here we go. Web client.builder.build. Now this endpoint, this is going to call our reservation service. So we need to secure it. So what I'm going to do is I'm going to use a filter here. I'm going to say exchange filter functions, basic authentication, hard code, don't do this, a username and password here, and we'll have our client. Now, what I want to do is I want to build an application runner that starts up and it injects the client and it makes a call to that service. So I'm going to say return args, like so, and I'll say web client dot get dot retrieve or dot URI HTTP localhost 8080/reservations dot retrieve. And here what I want to do is I want to take the JSON that's going to come back. It's going to be JSON that comes back, or XML, I guess, if I had specified the content type. I want to take the data that comes back and I want to turn it into a type of record here, a publisher of a mono or a flux, right? So I want to take it and turn it into a flux of reservation. Well, of course, I don't have the reservation class literal on the class path, so I need to go ahead and copy and paste the code. This is something terrible, something that you should never ever do, not even when you're all by yourself at home and nobody's looking. Copying and pasting. Okay, there we are. Very good. And now that I've got that, what I want to do is I want to unpack all of the names, right? So I can say names, or x equals x type get reservation name. That could be a method reference. And what that gives me is a publisher of strings, right? Names publisher. Actually, we can even do, yeah, that's probably fine. Let's try that, okay? So let's see if that works. We'll create instead of doing this, let's create a router function. Here we go, router function, like so. Routes, return, router functions.route request predicates.get names new handler function, and we're going to return a response that has the names in it, right? Adapting the downstream API based on our use case. This is a client-specific view. So server response.ok.body passing in the names publisher of type string, okay? And start that up. Clean the code in the meantime. Thanks. Oops. Thank you. All righty. Localhost 8081 names. Okay, so there we go. I'm able to reactively call the downstream service, and this is using the client directly, and this is a great use case for the client, right? I can do that. I can create custom views and so on, and if I'm calling downstream services that are going to send me a payload of unknown length, this is exactly what I want, right? But there's a lot of things that I want to do that are just based on proxying, right? I want to just send data, I want to just move data back and forth. And so there's actually another technology in Spring Cloud and the Spring universe called the Spring Cloud Gateway, which I need to add that to the class path here. So I already had it on the first one, but not the second one. Did I not add it to this one? Oh, it is. Yeah, here it is. Reservation. It's a Spring Cloud Starter Gateway. The gateway is a brand new project in Spring Cloud. It's reactive from the core. There's no way to use it in a non-blocking, in a blocking environment, for example. So the way you configure that is a route locator, routes, and what I'm going to do is I'm going to inject the route locator builder, RLB, and I'll say return RLB dot routes dot route, and we'll come back to that in a second, build. And here, I'm going to use the predicate spec to say that whenever somebody makes a request to, for example, RL, or guides, that I want to proxy data to some other endpoint. So here I can create a filter spec, and I can say gateway to filter spec. And what I want to do is I want to call, I can do all sorts of things. I can add custom headers, I can rate limit it, I can do all sorts of things there. Use a circuit breaker, do a redirect. Or in this case, I just want to send a request to another node. So in this case, I'll say spring.io:80/guides. So here I'm using the rate limiter, the gateway, to create a proxy so that when somebody goes to my localhost localhost 8081/guides, they'll be given the output as though they had called the guides endpoint, right? So localhost 8081/guides, right? All right. So we've looked at a number of different technologies here. A lot of different things going on here. That's the point, right? Hopefully some of this is pretty familiar to you. Hopefully some of this is straightforward. In this example, in this code base here, a lot of this will seem pretty new. The Spring Cloud Gateway is a new project that we introduced that's completely reactive. It's perfect for this kind of thing. We're calling downstream services of unknown length, and you want to be sure that you can't overwhelm your client when you make that call. The last thing that you want to do is to try and do a select all and then hold it in memory, right? On the other side, on the service should look pretty familiar, right? We looked at Spring Security. This is the user detail service for authentication. This is authorization. Basically, this is what you would have done in blocking sort of traditional Spring Security, but we've supported it now in the correct way in the reactive world. We have these functional reactive endpoints. You can use them if you like. These are by no means new or novel to Spring itself. Obviously, there's things like RxJava and Scalatra and Sinatra in the Ruby world, and Ratpack in the Groovy world, and Spark Java itself, and lots of great things that have tried this approach as well. And you can mix and match, right? That's the point. If you want to use these functional reactive endpoints, great. If you want to use the Spring MVC style controllers, great as well. And Spring Data itself as well. Spring Data provides this sort of familiar metaphor. It's just a repository. You have templates that you can use as well. So this should feel very familiar if you've ever used Spring before, but now you can take advantage of this new sort of paradigm. You can write code that'll do the right thing in the face of load when you're moving lots of data back and forth. And you can build better services that are more robust in the face of possible topology changes and so on. The biggest feature, of course, was the ASCII artwork. I think we can agree. So thank you so much for your time, Tak. I appreciate it. You're all very welcome to ask me questions if you have any of them, but I think we're going to be ushered off stage. Thank you so much.